In this video, we are going to solve problems from the worksheet for the end of term exam. The first objective is to define acceleration as the rate of change of velocity. We know that acceleration is rate of change of velocity, and its formula is given as delta v over delta t, where delta v is the change in velocity, so vf minus vi over time, and the unit for acceleration is given as meter per second square. Here the question says that a car is traveling west at 22 meter per second, which is its initial velocity. We can write vi here as 22 meter per second. After 10 seconds, its velocity is 17 meter per second. So vf, the final velocity, is 17 meter per second, and the time is 10 seconds. Find the magnitude and direction of car's average acceleration. So the first thing, we'll write the formula for acceleration, which is vf minus vi over delta t. Vf, the final velocity, is 17, but it is to the left, so we have to write it as negative 17, negative indicating that it's to the left, then minus, which is there in the formula itself, then start the bracket, and again negative 22. Over the time is 10. So this will be negative 17 plus 22 over 10, which you can calculate on the calculator, and that will come out as 0.5 meter per second square. So it is asking for magnitude and direction. Because we got the answer as positive, so that means the direction of acceleration is to the right. Either you can write the word right, or because they use the word west for left, so we'll write east. We can also say acceleration of direction is to the east. Next question, a car accelerates from rest to a speed of 40 meter per second in 5 seconds. So it accelerates from rest, so that is vi is equal to 0, to a speed of 40, so vf is equal to 40. The time is 5 seconds. Again, it's asking for acceleration, so a is equal to vf minus vi over time. So 40 minus 0 over 5, 40 over 5, which is 8 meter per second square, and that's our answer B. Okay, next let's look at the next objective. It is about sketch and interpret motion graphs. The slope of position time graph represents velocity. So we should know that if you have a position time graph, and if you find the slope of that graph, you're going to get velocity. And that slope can be 0, it can also be constant, or it can be positive or negative. It can also be a curved line. So if you have a curved line, it is going to represent that the object is accelerating. If you have a velocity time graph, so we can have two types of graph. We can have position time graph, we can have velocity time graph. The slope of a velocity time graph represents acceleration. The area under this graph, area under which graph? Area under velocity time graph is used for finding distance and displacement. So you need to remember all of these. Let's look at the first problem. A velocity time graph is shown for an object. Which statement describes the object's motion between x and y correctly? Between x and y. So first thing you should note is what kind of graph you have got. It's a velocity time graph. So the graph directly gives you information about the velocity. So if you look at x and y, we can see that there is no change. It's a straight line, horizontal line, so no change in velocity. That means it's showing us constant velocity. So our option here is C. Next, a graph shows velocity as a function of time for an object moving along a straight line. So object is moving in a straight line. For example, a car moving on a straight road. For which of the following sections of the graph is the acceleration constant and non-zero? Constant and non-zero, so you cannot have zero acceleration. So if you look at first thing, again as usual, we will check what graph we are looking at. It's a velocity time graph, and from a velocity time graph, the slope of the graph gives us information about acceleration. So if you look at PQ and TU, they are horizontal lines. Horizontal line means here the slope is 0, which means acceleration is 0. Here also the slope is 0, which means acceleration is 0. But they said we need non-zero acceleration. So PQ and TU cannot be our answer. Let's look at RS and TS. They are straight lines, but they are not horizontal. So their slopes are constant for both of them. They have constant slope, which means that acceleration is constant and also it's not equal to 0. So that means RS and TS, or RS and ST, that's our answer for this problem. Okay, next one. Which of the following graphs of position D versus time t corresponds to motion of an object in a straight line with positive acceleration? So we need positive acceleration, and it's a position versus time graph. So remember that a position versus time graph gives you information about velocity. It doesn't give you information directly about acceleration. But you know that if velocity is changing or velocity is increasing, that means you have a positive acceleration. So if velocity is increasing, we know that the graph has to be a curved line. So we can see that option D, you have a curved line. It is showing you that the velocity is increasing. How do I know velocity is increasing? You can see here the slope was horizontal, and as we move along the graph, we can see that the slope is increasing. The slope is increasing, and we know that slope gives us velocity because there's a position time graph. So that means velocity is increasing. Increasing velocity means that we have got positive acceleration. Okay, next two objectives: calculate acceleration from the slope of velocity time graph, calculate distance and displacement from the area under velocity time graph. So let's look at this problem. A particle starts out from the origin with velocity 10 meter per second, continues moving at this velocity for 5 seconds. Velocity is then abruptly reversed to -5 meter per second. An object moves at this velocity for 10 seconds as shown in the graph. So again, the first thing which you should notice is what kind of graph we have. It's a velocity time graph. It's asking you find the change in position or the displacement. So remember, change in position is same as displacement. So if the question asks you find change in position, that means they are asking for displacement. We know that displacement from a velocity time graph is the area under graph. So when we say area under graph, it means area under the plot line and the time axis. So always remember to focus on the time axis, because that's going to help you to find the area. So I'm going to shade the area under the graph, which we want to find is this area, which is the area under the plot line and the time axis, and this area. Okay, very important to shade so that we are clear about where is the area which we want to find. So this time axis and the plot line, the area under these two things will give you the area which you want to calculate. So this is a square or a rectangle. We know that the formula for area is length times breadth. So we can just find out what's the sides, what are the sides of this square. So this is 5 and this is 10. So we will get this area as 5 multiplied by 10. So let's just write down here 5 multiplied by 10. Then the next area, which is this one, here we can see that this length, if I want to find this length, this is 15 minus 5. This is important to note. This is 15 here, this is 5 here. So 15 minus 5 gives you 10. And the height here, or the other length, is minus 5. You can see that. Okay, so we can write the area as minus 5 multiplied by 10. So let's just write down the area here, which is 50 minus 50, which gives you 0 meter. That's the displacement. Next is, what is the total distance? So this time it's distance. So we know that for distance we have to put everything positive. So like in displacement, we took this as minus 5. One of the sides was minus 5, so we took it as minus 5. But for distance we are going to put it as positive. That's the only difference between displacement and distance calculation from the graph. So distance is also area under graph. We'll write the same thing, but we have to do 5 times 10 plus 5 times 10, so no negative. So that is going to give us 50 plus 50, which is equal to 100, and the unit is meter. Next is, what is the acceleration of particle during the first 5 seconds? Here we can write that slope is 0. It is constant, but it is equal to 0 because it's a horizontal line. So we can say that acceleration is 0. So we'll write here acceleration is 0 as the slope is 0. Okay, in question number 7, it is asking the velocity time graph for an object. For an object's motion is shown in the figure below. Describe the motion of the body at the time interval specified in the table. So we want to describe the motion of the body according to the graph which is given to us, and it's a velocity time graph. So from 0 to 3 seconds, so let's just label this as 0. From 0 to 3 seconds, we can see that the velocity is increasing uniformly. Uniformly means equal increase in velocity for equal increase in time. So we can write that velocity is increasing uniformly. And also we can see that because the line is a straight line, that means it has a constant slope. Constant slope means we have got constant acceleration, and it is a positive slope, so we can write constant positive acceleration. Then from 3 to 6 seconds, so from 3 to 6 seconds, we can see that the velocity is decreasing uniformly, and we have got constant negative acceleration. So here the slope was positive, whereas here it has got constant negative slope. So we'll write velocity is decreasing uniformly. And we can say that it's constant negative acceleration. Then from 6 to 9 seconds, which is from here to here, we can see the object has got negative velocity. So it was having positive velocity, now it has got negative velocity. And if you talk about speed, that is without the sign, we can see that at 6 seconds the speed was 0, and at 9 seconds the speed here is 10. Okay, so if I just label it here, the speed was 10 here, and here the speed was 0. So we can say that the velocity or the object has changed direction The reason for it is because the velocity before was positive, now the velocity is negative. But if you look at the speed, that is only the number. The speed is increasing because it was 0 at 6 seconds and 10 at 9 seconds. So speed is increasing. But then we can also see that it doesn't stop there. You can see that the line goes straight down to 0 at 9 seconds. So that means the object is coming to a sudden rest. So at 9 seconds, object comes to instantaneous. Instead of writing sudden, we'll write instantaneous. That means without taking any time. It comes to instantaneous rest. Okay, next is asking what is the average acceleration of the body at 6 seconds. So from a graph of velocity time, if we want to find acceleration, we know that it is equal to the slope. So we'll write acceleration is equal to slope, which is equal to y2 minus y1 over x2 minus x1. So at 6 seconds, we can see that there is a line which is passing through that 6 seconds. So we need to find what's the slope of this line. We can take any 2 points. So I'm going to take a point here, and this coordinate of this point will be 3, 10, and this point, the coordinate is 9, negative 10. So we can write these values: y2, which is negative 10, minus y1, which is 10, over x2, which is 9, and x1, which is 3. So minus 20 over 6, which is going to give us negative 3.3 meter per second square. That's for acceleration. Then it's asking us what is the final displacement of the body. So displacement is area under the graph. So, and it's asking for final displacement. That means we want to find the area of the whole graph. So let's just first write down displacement is equal to area under graph. And then let's check what the graph looks like. So we have got a triangle here. Let's shade that. We want to find the area of this triangle, and we want to find the area of this triangle. Okay, so for the first triangle, we can see that the base of the triangle is 6 and the height is 10. And triangle, the formula is half base times height. So we can write half times 10 times 6 plus the second triangle, the base, this base will be 9 minus 6. So here, if I want to label the base, this base will be equal to 9 minus 6, which is equal to 3. And the height is negative 10. And because we are calculating displacement, we will keep it as negative. So half times 3 times negative 10. We can calculate this: 30 minus 15, which is going to give us 15 meter. Okay, now let's look at these sets of questions, because it's saying it's for questions 8 to 10. We are going to use this graph which is shown here. So the first question is asking you find car's acceleration at 2 seconds. So at 2 seconds, I'm just going to check what's happening in the graph. Okay, we have got a straight line. So we want to find the slope of this graph. So let's just first write that acceleration is equal to slope. and which is y2 minus y1 over x2 minus x1. And I need to take any 2 points which I can read easily from the graph. So on the graph, I'm going to check this point. I can see that I can read it properly. It's 3 and 8, and I can take 1 point here which is 0 and 0. So just let's label that. This point will be 3 comma 8, and this point will be 0 comma 0. So that will be 8 minus 0 over 3 minus 0, which is going to give us 2.67 meter per second square. So our answer is B. Next, find the displacement of the car between 5 seconds and 9 seconds. Now it's not asking for total displacement, it's asking specifically between 5 and 9 seconds. So we have to be careful about when we are calculating the displacement from the graph. So let's just shade the area. We can see that this point is 5 and this point is 9. So we want to find this area under the graph which is above the axis, and also this area above the graph which is below the axis. Both of them are triangles, so it will be half base times height. So let's write down displacement is equal to area under graph. So for the first triangle, half base, look at the triangle, the base here is from 5 to 7. So let's just label this point as 7. So from 5 to 7, the base is going to be 2. 7 minus 5 is 2. So 2 is the base, and the height is 8. So we can write that 8. Plus, again let's repeat, half base times height, half times, let's look at the base, 7 and 9. So 9 minus 7 gives you 2. The base is again 2. And the height is negative 8. And because we are calculating displacement, we will keep it as negative 8. If we calculate this, we'll get the answer as 0 meter. So answer here is C. Next, find the total distance covered by the car during the 9 seconds. So now it's asking for the whole journey from 0 to 9. So we'll go back to the diagram, and this time we want to find the area of the rest of the graph as well. So let's just divide this area into 2 more parts so that we can easily see that there is a triangle here and we have got a rectangle here. So for triangle, let's write down again, distance is equal to area under graph. So for the first one, it will be half times the base. To find the base, we need to label this point, which is 3. So half times 3 times 8. 3 is the base, 8 is the height, plus then this is a rectangle. For rectangle, the formula is length times width. So we can see that one of the sides is 5 minus 3 is 2 and the other side is 8. So we will write it as 2 multiplied by 8. Okay, plus we already found the area of this triangle which we wrote here and the area of this triangle which we wrote here. So we'll just copy that. So half times 2 times 8. But then when we copy the last one, we can see that for displacement we've put it as negative, but because we are calculating distance, we are going to put it as positive. So this is going to be 12 plus 16 plus 8 plus 8, which is going to come out as 44 meter. Okay, let's check the next page. Now we have got a set of equations to solve for objects which are moving with uniform acceleration. So these equations will be there in the equation formula sheet. You need to choose it or take the formula from the formula sheet. So for that, first we'll write the given and then we'll choose the formula. So for the first one, particle has an initial velocity of 2 meter per second, acceleration of 4 meter per second square. Find its displacement after 10 seconds. So VI, initial velocity, is 2 meter per second. Acceleration is 4 meter per second square. We want to find the displacement, that is delta x, and the time is given as 10 seconds. So if you look at VI, A, delta x and t, these are the four things which we are dealing with or which we want in our equation. So we can see that this equation has all of them. So we'll copy that. Delta x equal VIT plus half AT square. So 2 multiplied by 10 plus half times 4 times 10 square, which is going to give us the answer as 220 meter. Next, a car slows down from a speed of 31 meter per second to 12 meter per second over a distance of 380 meter. How long does it take, assuming constant acceleration? So slows down from a speed of, so VI is 31, VF is 12, the distance covered is 380 meters. How long means it's asking for time. So again we check, we have got VI, VF, delta x and t, and we need to choose a formula where all of this comes together, and we can see that happens here. So we'll copy that formula. Delta x equal VF plus VI over 2 multiplied by delta t. So 31, let's write it in the same order, 12 plus 31 over 2 multiplied by t, and delta x is 380. So we know delta x and we want to find what is t. You can do shift solve on your calculator. We'll get the time as 17.7 seconds. Next is asking for acceleration. Now we have got time 17.7. We have got VI 31 meter per second, and we have got VF 12 meter per second. So AT, VI and VF, they come together in the first equation and we will use that. So VF equal VI plus AT. So 12 equal 31 plus A multiplied by 17.7. And we can use our calculator to get this. I will just use it. I get the answer as negative 1.07, and we can put the unit as meter per second square. Okay. Next question, a car starts from rest. So VI is equal to 0. Accelerates at 10 meter per second square. How far does it travel? So delta x we want to find, and the time is given as 2 seconds. So we need to use the formula where we have VI, A, delta x and t coming together. VI, A, delta x and t. So that is this second equation. Delta x equal VIT plus half AT square. VI is 0 multiplied by 2 plus half multiplied by 10 multiplied by 2 square. That's going to give us 20 meter. Next, airplane starts from rest. So VI is equal to 0. Accelerates at 12.1 meter per second square. What is the speed at the end? So VF we want to find. End of a 500 meter runway. So delta x is given as 500 meter. So we will choose the formula where all four of these come together, and which is Vf square equal Vi square plus 2a delta x. So Vf square equal 0 square plus 2 multiplied by 12.1 multiplied by 500, and solving this with your calculator will give you the answer as 110 meter per second. Next, complete the table stating whether the quantity is vector or scalar by giving full name of its unit. So it's asking for, is it vector or scalar? Vector is a quantity which has both magnitude and direction. Scalar is a quantity which has only magnitude. Okay, so vector has both magnitude as well as direction, and scalar has only magnitude. So momentum is a vector quantity. Weight, which is another name for force of gravity, because it's force, so that's also a vector quantity. Kinetic energy is a scalar quantity. Power is also a scalar quantity. Now we want to give the unit. Unit for momentum is kg meter per second or Newton second. Unit for weight is Newton, and if you want to write, because they are saying full name of the unit, you can also say in bracket it stands for Newton. Just write the whole word. Kinetic energy is joule, and power is watts. Which of the following represents correct vector and scalar quantity? So vector, the first quantity should be vector, the second quantity should be scalar. Electric charge is not vector. Impulse is a vector quantity. Current is a scalar quantity, so that means B. Which of the following statements about scalar quantities is incorrect, not correct? So scalar quantities contain a magnitude only, that's correct. Mass is a scalar quantity, yes. Scalar quantities contain both magnitude and direction, that's wrong. So C is our answer. Now we have got questions on components of a vector, so we will be using cosine theta and sine theta. Here we have got a vector of 10 units, and we want to find what's the x component. We know that because x axis is making the angle, so it will take the cosine, so 10 cosine 76, and the y axis will get 10 sine 76. So we need to just choose the correct answer, which is A. Again, same thing, we want to get x and y component. This time y component is making the angle, so we'll write it as f cosine theta for y, because y component is making the angle, and because they already stated it's negative and we know that it is down, so it should be negative, so negative f cosine theta, and this will be f sine theta, again negative. So x component is negative f sine theta, y component is negative f cosine theta. Next, we want to solve questions based on free fall. So these are the equations for free fall, and in all these equations g will be taken as 9.8 meter per second square, and because the equation already has negative sign with it, you don't have to put a negative sign for g. Okay, in case if you are using the equations with positive sign, so I'll just show you what do I mean. If you are using Vf equal Vi plus At, delta y equal Vit plus half At square, Vf square equal Vi square plus 2a delta y. If you are using these equations, then you will write acceleration as negative 9.8 meter per second square. So it's your choice which equation you use. Let's read the first one. A stone is thrown upward from ground level with an initial velocity of 10 meter per second what is the velocity of the stone after 0.5 seconds. So Vi is 10. They are asking us to get Vf. Time is 0.5 seconds and G value is 9.8 meter per second square. Because I wrote G, so I'm going to use the equations from this block. So we are going to use Vf equal Vi minus Gt. So 10 minus 9.8 multiplied by 0.5, which gives us 5.1 meter per second. Then we want to find how high does it reach. So that means delta Y we want to find. So delta Y is Vit minus half Gt square. We'll write 10 multiplied 0.5 minus half multiply 9.8 multiply 0.5 square, which is going to give us the answer as 3.775, and we'll put the unit meter. Next, an object is thrown vertically upwards with an initial velocity of 20 meter per second from the edge of the cliff, that is 30 meter from the sea below. So the distance or the height of the object itself from the sea, so here we have got sea, is 30 meter. Determine the ball's maximum height. So we know that the ball is going to travel up, reach to a maximum height, and then it's going to move down, change its direction and hit the sea. So it goes up and then it comes down and hits the sea. Let me draw it straight. Yeah. So this point is the maximum height. Question is asking us to find this maximum height. We know that at maximum height the velocity will be 0. So Vf is 0 for maximum height. And we want to find what is delta Y. G is 9.8. So we can use the equation Vf square equal Vi square minus 2G delta Y. 0 square equal 20 square minus 2 times 9.8 times delta Y, which is going to give us the value of delta Y, which will be 20.4 meter. So remember, this 30 meter is not the maximum height. So delta Y, this delta Y is for the journey. So it's the total displacement. It's not the maximum height. Okay, which we'll be using for then maybe for part C. But for part A, it's asking for maximum height. So we want to find how much distance the ball covered from its initial position to the maximum height. And at maximum height, velocity will be 0. Okay, then it's asking you the time taken to reach the maximum height. So we want to find T. What is given to us? Vi is 20 meter per second. Vf is 0 because we are talking about maximum height. G is 9.8. And time is what we are trying to find. So we'll use Vf equal Vi minus Gt. 0 equal 20 minus 9.8 multiplied by T. And this is going to get us the value of T as 2.0 seconds. Then time to hit the sea. So we need to know that it starts from here, the ball starts from here and ends here. So for this whole journey, its shortest distance from the start to the end, which is the displacement, is 30 meter. So delta Y will be 30, but we are going to write it as negative because it's going down. And then the rest of the things we know, Vi is 20 meter per second, G is 9.8 meter per second square, and the question is asking us to get the value of time. So we'll use delta Y equal Vit minus half Gt square. So that is negative 30 equal 20t minus half times 9.8 t square. I'm just going to simplify it. and this will become 4.9 t square, and then I'm going to rearrange it in the form of quadratic equation, so power 2, because we can see t is having a power 2. So in order to solve this, I'll have to use mode 5(3) on the calculator. So on the calculator you're going to use mode 5(3), but before using it I need to arrange it. So I'm going to move all of these to the other side. So it will look like this: 4.9 t square minus 20t minus 30 equal 0. So this is A in mode 5(3), negative 20 is your B, and negative 30 is your C. So on your calculator you will press mode 5(3), then enter the value for A, enter the value for B, enter the value for C, press equal. We'll get the value for time as 5.2 seconds. It will give you two values. One value will be negative. Negative value is not allowed for time. So your answer will be 5.2 seconds. Next, a ball is thrown vertically upward with an initial velocity. Which of the following velocity time graph describes the motion of the ball as it goes upward? So when the ball moves up in the upward journey, we know that its speed is going to decrease. Okay, and we know acceleration due to gravity is a constant value, so that means it should be a straight line. Velocity time graph should be a straight line, and the only option which has this is C. We can see velocity is decreasing and the graph is a straight line. Next, the same thing, but now they are asking when it goes downwards. So when it goes downwards, we know that its speed is going to increase. And again, acceleration due to gravity is a constant value, so we should be having a straight line. So the answer will be B. You can see actually the graph, the velocity is increasing here as well as the velocity is increasing here. But this is a straight line which shows us the slope is constant, which means the acceleration is constant, which matches with free fall, because acceleration of free fall is a constant value. Here the slope is increasing, which means that the acceleration is increasing, and that's why it is wrong, because in free fall acceleration remains constant. Okay, next we are having projectile motion questions. It's asking us, it's describing a projectile motion, and it's asking us to select a graph which shows the correct graph for horizontal velocity and vertical velocity. So in projectile motion, we know that VH remains constant. That is, horizontal velocity does not change. And the only graph which shows that is D. So VH is constant. And let's just look at vertical velocity as well. We know that when you throw something up, as in the projectile motion, its velocity will decrease. Then it reaches zero at the maximum height. And then it changes direction. You can see that the graph is going in the negative side, and the speed keeps increasing. So that graph is also correct. Next, we want to sketch the graphs to show the variation of horizontal and vertical components of velocity and acceleration. So we already said Vx is constant. So for Vx, we'll have the graph just a straight line parallel to the time axis. And obviously, if Vx is constant, then Ax must be 0, because the velocity in x direction is not changing, so acceleration must be 0. So that will be a line which will draw on the time axis to show that acceleration is 0. Then for vertical component, we know that Vy will first decrease. Why decrease? Because you are throwing something up, so its velocity will decrease. okay, and then it will reach 0 at maximum height. Then what does it do? Then it changes direction. That means it will now start moving downwards. So Vy will first decrease. So we should have a line like this showing that velocity is decreasing. Then it reaches 0. This is going to happen at maximum height. And then it should go to negative side of the graph, because we know that the object has changed direction, and its speed is continuously increasing. Okay, so Vy will first decrease. It reaches to 0 at maximum height, and then it changes direction. And acceleration in y is a constant value, which is negative 9.8 meter per second square, which is acceleration due to gravity. So we'll just draw a line in the negative side of the y-axis and label that as negative 9.8. Okay. Now here we want to find, for a projectile motion, what are the x and y components of the initial velocity. So for a projectile motion, x component is always v cosine theta and y component is v sine theta. So we have to just use the angle here which is given and the velocity which is given to us to find what is Vx and Vi. So Vx will be 18 cosine 30, which is 15.6 meter per second, and Vy is V, that is 18 sine 30, which is 9 meter per second. Next, the angle is 0. So Vx is 18 cosine 0, which will give us 18 meter per second. And Vy is 18 sine 0, which is going to give us the value as 0 meter per second. Then the value is 90 degree. So Vx is 18 cosine 90. Cosine 90 is 0. So you will get this answer as 0 meter per second. And Vy is 18 sine 90. Sine 90 is 1. So we'll get this answer as 18 meter per second. Okay, next we have got a full question on projectile motion. So we want to solve this. And as I taught you in the class, for projectile motion, you can always draw a table to understand what's happening on the x-axis and what's happening on the y-axis. So I'm going to draw that table here. Again, the table is not required for the exam to gain marks, but it helps us to understand what's happening on x and y axis. So I'm just going to draw it. So in the x direction, initial velocity will be 20 cosine 30. In the y direction, it will be 20 sine 30. Then the acceleration in the x direction, we know it will be 0 because speed or velocity in x direction does not change, and the y direction it will be negative 9.8. Then displacement in the x direction, we call that as range, and the y direction we can see that it starts from the ground and hits back on the ground. So the displacement in the y direction is equal to 0. We want to find what's the time of flight. Time of flight means the time taken for the whole journey. So it started from the ground and it reached the ground. So time taken for the whole journey we want to find. We can find time using x values or using y values. If we look at our table, we don't know what's range. So we will not use x values. Instead, we'll use y values because we know what is Vi, we know what is acceleration, we also know what is displacement. So we'll write that Vi is 20 sine 30. So I'm using y values. Acceleration is negative 9.8. Displacement, which is delta y, is equal to 0. And also we know one more thing, because it's starting from the ground. So if I want to show it on the diagram, so this value actually comes out as 20 sine 30. So it starts with 10 meter per second upwards, and when it reaches the ground, its velocity, vertical velocity, this is the vertical velocity, and the final vertical velocity will be negative 10 meter per second, because it's going down. So we can also write that negative 10 meter per second. Now from the equations which will be given from the formula sheet, you have to choose the correct equation for this. So I'm going to write Vf equal Vi plus At. Again reminding you, if you use Vf equal Vi minus Gt, then G value will be 9.8 without the negative sign. So this is negative 10 equal 10 plus negative 9.8 multiplied by T, and this answer is going to come out as 2.04 seconds. Next we want to find what's the range. Range formula for projectile motion is given to us here. You can see that this is a range formula. So range formula is Vxi multiplied by time of flight. So initial velocity in x direction is 20 cosine 30, and the time of flight is 2.04. So we get this answer as 35.3 meter. Next it's asking us to calculate the maximum height. Now maximum height, this is the point of maximum height. So the ball will take half the time of flight to reach to the maximum height. So we already got the time as 2.04. So the time to reach the maximum height will be 2.04 divided by 2, which is 1.02 seconds. And the rest of the things we know it. Vi, because it's vertical, maximum height is vertical, so we will be using vertical values, so y values. Okay, remember height is in the y direction, so we have to use the y values. So 20 sine 30, which is equal to 10 meter per second. Acceleration is negative 9.8, and then we can use the formula delta y equal Vit plus half At square, and Vi is 10 multiplied by 1.02, then plus half, A is negative 9.8, and the time is 1.02 square. This, if you calculate, it will come out as 5.1 meter. Okay, question number 32 is also on projectile. A projectile is launched from top of a building with an initial velocity of 30 meter per second at an angle of 60 degree above the horizontal. So if you want to just visualize it, you have got a projectile, let's say a ball, which is thrown upwards with 30 meter per second, and it makes an angle of 60 degree. The question is asking you find the y component of its velocity 5 seconds after the launch. So we want to find Vf for y component. It is telling us the time is 5 seconds, and we know that acceleration, or the value of g for the y component, so let me write it as acceleration. Acceleration is negative 9.8 meter per second square. If you write g, you have to write it as positive. I'm going to use it as negative here, okay, because I'll use the formula with the positive sign. So it's asking for the final velocity, the time is given, acceleration we know for the y component, We can also find out the initial y velocity because this information is given to us, which will be 30 sine 60. We know that the y component will take the sine. Now we can use the formula Vf equal Vi plus At. So 30 sine 60 minus 9.8 multiplied by 5. This will give us the answer as negative 23 meter per second. Next is asking magnitude of x component, that is a horizontal component. We know that horizontal component remains constant. So we have to just find what's the initial x component, which we know will be 30 cosine 60, which will be 15 meter per second. So the final y component in the x direction will also be 15 because horizontal component remains constant. Next is asking for net velocity, which means total velocity at 5 seconds. So V net, the formula for V net we have to use. So we can just understand what the question is saying. Like, let's say that you are throwing the object. Okay. So the projectile is thrown with 30 meter per second at 60-degree angle. After 5 seconds, let's say the projectile reaches here. So the horizontal component of the projectile is 15 meter per second. This is after t equal to 5 seconds. Okay. We already found the horizontal component is 15 and we also found the vertical component is negative 23. So we can draw it. This is negative because it's going down. So 23 meter per second. I'm not writing negative because I showed that it is going down. So the angle between them is 90 and the question is asking you find V net. So V net will be along this line. This is V net. So we are going to use the Pythagoras theorem. V net square equal Vx square plus Vy square. So V net will be equal to square root of Vx square plus Vy square, which is equal to 15 square plus 23 square, which will come out as, let me just calculate this, 15 square plus 23 square. That gives us 27.45, so 27.5 meter per second. Next we are having questions on drag force and terminal velocity. Terminal velocity, you should know that it's the constant, highest maximum constant velocity reached by an object when it is falling freely in air. Okay. The question here is asking you which point on the graph represents terminal velocity. We know that terminal velocity is constant velocity. So the point which represents it on the graph is D. Next, the figure below shows how the speed and acceleration vary for motion of a body of mass m dropped from some height with air resistance given by F equal kV. So this F equal kV is for air resistance. Air resistance also means it is the drag force. Okay, and we know that on an object which is falling in air, there will be force of gravity acting on it and there will be drag force acting on it. And if it has reached terminal velocity, then the drag force and the force of gravity must be equal to each other. Okay, so we will start with that equation. F drag is equal to Fg. F drag, we know from the question it is kV, so I'll replace it with kV equal Fg. Now Fg also, we know the formula is mg, so we can replace that with mg. Question is asking us to derive an equation for terminal velocity. So I want to keep v by itself, so I'll divide both the sides by k. So I get the value or the formula for terminal velocity as mg over k. Okay, which statement about Newton's second law is true? Newton's second law is F net equal ma. So if you, first of all, the mass in Newton's second law must remain constant. So if it is written non-constant mass, that is wrong. Now if it's written constant mass, let's read the whole thing. Resultant force acting on it is inversely proportional to acceleration. Again, it's wrong, because net force is directly proportional to acceleration. The more force you apply, the more the net force, the greater the acceleration. So the answer is C. Force of 100 Newton is applied to an object of 85 kg. What is object's acceleration? So F net equal ma. F net is 100, which is equal to 85 multiplied by a, we want to find. And if you calculate that on your calculator, we will get the answer as 1.176, which is 1.18. Okay, next, a small object P is suspended by a vertical light string. It is then pulled to one side, so we'll draw it on the diagram, by a force which is equal to its weight. So the weight should have the same length as the force which we have drawn. So this will be the weight. Okay, and it is held stationary. So if these two forces are trying to pull the object, there will be definitely a tension force acting, and that tension force will be on the string like this. So our answer will be A. Next, a photo hangs from two strings. It has weight W and two strings have equal tension T. What is a free body diagram for this situation? So always remember, let's just see how it looks like to hang the picture. So this will how it will look like. You have a picture, you are hanging it with the help of two strings. So when you are hanging it from some support, so this is your support. Okay, tension force will always act towards the support, and the weight obviously will act downwards. So our answer here will be C. Tension force is up and weight is down. This one doesn't show the arrow for the weight, so that's why we'll not choose this. Two blocks A and B are joined by a string and rest on frictionless horizontal table. A force of 200 newtons applied horizontally on block B. Draw the free body diagram for both the boxes. So when they ask you to draw free body diagram, you must draw it separately. So I'm going to draw for A separate and B separate. So on A, there will be force of gravity acting, which is mg, and there will be normal force acting, which is Fn. I'm going to write as Fna just to show that it's the normal force on object A. There will also be tension acting because it is connected to B with the help of a string. So that tension I'm going to draw it as T. And just to make the arrows equal, I'm just going to redraw this. Mg and Fna must be equal to each other. Then for B, we repeat it for B. On B, we can see that there is 200 Newton acting, so we have to show that 200 Newton. Also, it is being pulled by A with the help of the string, so the tension force exactly same as that of what we drew on A. The same thing we have to draw for B. There is mg for B, and there will be the normal force acting upwards for B. Okay, so we have got the free body diagram ready. always remember that when you draw the free body diagram, draw it separately for the boxes. And also one more thing, the normal force is also sometimes called as reaction force. So if you want, you can write Fn as R also. Okay, the next one. A remote control boat has a mass of 0.6 kg and is accelerating with a resultant force of 1.95 Newton. Draw a free body diagram showing and labeling the forces acting on the boat. So we want to draw free body diagram for the boat. So I'm just going to draw the boat as a dot. I know that there will be weight acting downwards, force of gravity. Because it's in water, there will be upthrust acting upwards or buoyant force. It's being pulled by the engine to the right. So there must be a force of engine, which I'm going to just write as forward force. And because the man is holding the boat with the help of a string, so the boat is being pulled by the man with the help of the string backwards, that is to the left. So I have to show that as well, tension which is acting backwards. Okay, you can also show drag force acting on it, because air, there will be a force because of the air acting, the drag of the air, which will always also to the left. Then it's asking us to calculate the acceleration. Acceleration is F net over mass. They said that resultant force or F net is 1.95 and the mass of the boat is given as 0.6. Straightforward, we just substitute, we get the answer as 3.25 meter per second square. Next, what is the magnitude of force F in the figure given that the block is in equilibrium? Equilibrium means it's not moving, it's at rest. So force on the left side should be equal to the force on the right side. So we have got 15 on the left, on the right side we have got 6 plus F plus 6. If you solve this, we'll get F as 15 minus 12, which is equal to 3 Newton. Okay. Next, in the following examples, calculate the force required to balance the forces. So the first one is quite easy. We have got 60 Newton to the right, 60 Newton to the left, 40 Newton up, so it should be 40 Newton down. So F here will be 40 Newton. For the second one, we have to use components. We can see that there is 40 Newton force acting at an angle of 30 degree with the vertical. So angle is made by the vertical, so you will have a component of 40 Newton along the vertical, which we'll write as 40 cosine 30. Again, there is another component from the left side because you have got two forces acting. That will also be 40 cosine 30. And these two forces together, 40 cosine 30 plus 40 cosine 30, they balance out the downward force. And if we calculate this, we will get this as 69.28 Newton downwards. This is also downwards. Next, if the following two examples are in equilibrium, calculate, again they are using the word equilibrium, calculate the unknown forces F1, F2 and F3. So in the first diagram, the unknown force is F1. We have got two forces, 6 Newton acting, and they both make 45 degree with this line. So we'll use components because this line makes the angle 45. So we'll have 6 cosine 45 from the top force. Again, we'll have another 6 cosine 45 from the left force. So these two forces, 6 cosine 45 plus 6 cosine 45, they are opposite to F1 and they must also be equal to F1 because we need to balance, we need to have equilibrium. So let's just calculate this. 6 cosine 45, we have to do it 2 times. We get this as 8.5 485. So we can write it as 8.49 Newton. So that is F1. Next, in the next problem again, we have got unknown forces F3 and F2. We want to calculate them, and there is another force 20 Newton which is making an angle. So we'll first find the components of this on the diagram itself. This is 20 cosine 30. X is making the angle, and there will be 20 sine 30, the vertical component. Because it's in equilibrium, so along the x-axis, the forces along the x-axis, this is your x-axis, we can see there is 20 cosine 30 to the right and F2 to the left. So these two forces must be equal to each other. F2 is equal to 20 cosine 30, which will be 17.32 Newton. And along the y-axis, which is this, we can see that there are two forces acting up and one force acting down. So we'll write that as F3 plus 20 sine 30 is equal to 60, because again it's in equilibrium, so the upward forces must balance the downward force. We can calculate this. This will come out as 50 Newton. Okay, next in the table below, identify the forces as contact and non-contact forces. Now that's easy. I'm just going to write contact as C and non-contact as NC. Friction is contact force. Force of gravity is non-contact. Normal reaction is contact. Tension is contact. Air resistance is contact. Buoyant force is contact. Electric force is non-contact. Magnetic force is non-contact. Okay, direction of the normal is always means always correct answer. We have to always correct. It should be true for all cases. So it's always perpendicular to the surface of the contact. So normal force is always perpendicular to the surface with which the object is in contact. Normal force is a contact force that acts at the surface between two objects. Which of the following statements concerning the normal force is not correct? This is very important to note. Not correct. So normal force is always equal to force of gravity? No. It's not always equal to force of gravity. Okay. So our answer here is A. So you might be thinking how it is not always equal to force of gravity. So you can think of the ramp or the inclined plane. If you remember inclined plane, when we had an object on an inclined plane, the normal force is perpendicular to the surface like this, whereas the gravity is acting vertically downward. So in this case, normal force is not equal to force of gravity. So saying that it is always equal is wrong. Buoyant force acts in which direction? Very easy. It acts in upward direction. Object will not sink if its weight is less than or equal to buoyant force. An object sinks when the weight is more than the buoyant force. A 5 Newton stone is dropped in a lake and it sinks. Okay, so you have got an object whose weight is 5 Newton and they say that it is sinking. We know that there will be FB, buoyant force, acting. So if it is sinking, that means 5 Newton must be greater than FB, or I can say FB must be less than 5 Newton. Next, a 2.5 kg block of metal with volume 2 times 10⁻³ m³ is totally submerged in water. Calculate the buoyant force on the block. Just to recall, density of water will be provided. It's a constant value which is 1000 kg per m³. So buoyant force, the formula for buoyant force is density multiplied by density of fluid multiplied by the volume of fluid displaced multiplied by G. So 1000, they said that it's totally submerged, so all of the volume we have to take, multiplied by 9.8. Okay, so this answer is going to come out as 19.6 Newton. Explain if the object will sink or float. So we need to know what's the weight of the object. We can calculate by mg. They said that the m is 2.5, so 2.5 times 9.8. I'm just going to calculate that. 2.5 times 9.8 gives me 24.5 Newton. And I can see FB from my previous answer is 19.6. So weight is greater than FB. That means it's going to sink. Next, what is a buoyant force on a 20 kg box that displaces 4 meter cube of water? So we'll use again the formula, rho of fluid multiplied by volume of fluid displaced multiplied by G. So 1000, it displaces 4 meter cube, so 4 times 9.8, and this will come out as 4 times 10 to the power 4 Newton. Ball of metal is thrown into the lake. So you are dropping it into the lake, the whole thing is inside the lake. What happens to the buoyant force as it sinks deeper into the water? Okay, so buoyant force actually depends on how much water you are able to displace. But in this case, the block of metal is thrown into the lake. That means all of it is completely submerged. So the volume displaced will always be equal to the volume of the block itself. So volume displaced is not changing. If the volume displaced is not changing, the buoyant force will remain constant. So it remains the same. Okay, a force F is applied to a box on a rough surface, so there will be friction, and the box moves to the right with a constant velocity. So constant velocity means acceleration is equal to 0, which means F net will be equal to 0. So all the forces, left force should be equal to right force, up force should be equal to down force, and that is shown by C. Okay, D is incorrect because here right force is greater than the left force. That means the object is accelerating. Velocity cannot be constant. So our answer is here C, because left and right, up and down, all the forces are equal to each other. Next, we have got a diagram here. 100 Newton force is required to accelerate 5 kg box across a horizontal concrete floor. The box accelerates at 1 meter per second square. What is the frictional force on the box? So we are going to start with F net equal MA. There are two forces acting on the object, one to the right, one to the left. So we have to subtract the forces to get F net, and we will we'll write it like this: 100 minus force of friction, because the object is moving to the right, equal 5 multiplied by 1. If we calculate this, we get the answer as 95 Newton. Next, here we want to, there's a skier who is being towed at a constant speed while sinking into the snow. So he's sinking, he's not at rest, he's sinking into the snow. This is important to note. They are just asking to label or to name the forces A to D. So force A, you can see that that is resistive force because it's acting opposite to the direction of motion of the skier. So that is friction. B, there is a rope. They have labeled that there is a rope, so that means it should be tension force. C will be obviously force of gravity. and D is the normal force or the reaction force. Okay, which of the following statements are true? So they said he is moving with constant speed and he's sinking. So if he's moving with constant speed in the x direction, FB and FA must be equal to each other. So this is true. And if he's sinking, he's going in, that means C should be greater than D. Okay, this is because he's sinking. This is because he's moving at constant speed. The skier is pulled to the snow onto an area of grass and becomes stuck. So he's not moving anymore. State the type of friction present between the bottom of the skis and the grass when she is stationary. So that will be static friction. Mass of skier is 52 kg. Coefficient of friction is 0.12, so m is equal to 52. Mu is 0.12. What is the minimum force needed for the rope to get the skier just on the point of moving? So you're pulling the skier with the rope and you want him to come out and come out of the grass and become unstuck. So that means you have to apply a force which will be equal to maximum static friction. So I'll just write that, force which should be equal to maximum static friction. And formula for maximum static friction is mu Fn. Mu is given as 0.12. Fn in this case is mg because he is not sinking anymore. So 52 multiplied by 9.8, which is mg. Fn is 52 multiplied by 9.8. I'm just replacing it here. If you calculate this, it will come out as 61.1 Newton. So at least this much amount of force has to be applied on the skier so that he can come out of the grass and is about to move. Okay, next we have got momentum questions. So momentum, P is equal to mv. Here is asking you greatest momentum. We have to just calculate momentum for each one of them using the formula. If you use the formula, the first one will be 250. Second one will be 375. Third one will be again 250. So it's asking for greatest, which is for object 2. Same question repeated, 1.2 grams, same concept. We have to use P equal mv, but 1.2 is in grams. We need to convert that into kg, so we'll divide by 1000 multiplied by 800. This will be 0.96 kg meter per second, which is B. Okay. A ball rolls on the floor towards a wall and rebounds with the same speed at the same angle to the wall. What is the direction of the impulse applied to the ball by the wall? To the ball by the wall. So the wall is going to push the ball towards the left direction. So the impulse applied by the wall on the ball will also be towards the left. Okay, next we want to find, so we have been given all the values here. A ball of mass of 3 kg collides with a wall and rebounds. Initial and final velocities are given. Collision lasts for 0.2 seconds and we want to find what's the impulse delivered. So impulse formula is mvf minus mvi. The mass is given as 3 times vf is 15 minus again 3 times negative 20. which will come out as 105 kg meter per second. Then it's asking for average force. So we'll use the formula for average force, which is average force, you can write it as delta P over T. In the formula sheet, maybe you will see this equation, J equal F average multiplied by delta T, which you can rearrange it, or you can use this this formula itself to get F average from the impulse formula. Okay, we need to know that impulse is change in momentum, so I'm just writing it as delta P. Instead of writing impulse, I'm just writing it as delta P because both of them are same. So we actually calculated delta P, which is impulse here. So we are going to write that as 105 over 0.2. Okay, a time is given to us, which will come out as 525 Newton. If you want, you can write here J instead of delta P, if that makes it easier. Okay, in a crash test, a car of mass 1500 kg collides with a wall and rebounds. The initial and final velocities are given. Again, collision lasts for 0.150 seconds. Again, the same type of questions, it's asking for impulse delivered. Formula we'll use. The mass is 1500 times 2.6 minus 1500 times negative 15. This will come out as 26,400. Put the unit kg meter per second. That's done. Then you want to find average force, which is impulse over time. So 26,400 over time is 0.150, which will be 176,000, and put the unit Newton. Let me just double check the answer. Yeah, okay, that's correct. Next, a ball of 0.4 kg travels horizontally, strikes a vertical wall with a speed of 5 meter per second, rebounds with a speed of 3 meter per second. Contact time is 0.2. It's asking for magnitude of average magnitude of force. So F average is equal to impulse over time. Impulse is mvf minus mvi over time. So its initial speed was 5 meter per second to the right, so that will be positive. Final speed is 3 meter per second to the left, so we have to take it as negative 3 meter per second. So remember, in this problem, they did not give us the velocities, they gave us the speed. In all the questions above it, you can see that they are directly giving us what are the velocities. So if they give you a question like this where they are talking about the speed, then you should check the direction, and according to that you have to put the signs for the velocity. So here initial velocity was to the right, so 5 meter per second is positive. Final velocity was to the left, so I will write it as negative. Let's put the number 0.4 times negative 3 minus 0.4 times 5 over time, which is 0.2, and this will come out as negative 16 Newton. And because they are asking for magnitude, I don't have to worry about the negative. I'll just select the answer as 16. Okay, next, ball A of mass 0.75 kg moving at 5 meter per second. So I'm going to draw a diagram for it. Ball A 0.75 kg moving at 5 meter per second collides with ball B of 1.8 kg, and it's initially at rest. So this is before collision. After collision, ball B moves off with a velocity of 1 meter per second to the to the right. So for ball A, we don't know what's its velocity. We will just say that, let's say it moves with a velocity v. You can also write it as x. And ball B is moving with 1 meter per second to the right. So this is after collision. So we'll write total momentum, P total, before collision is equal to total momentum after collision. Okay, you can write the whole sentence. I'm just writing in short. I'm writing total P before collision is equal to total P after collision. So before collision, we can see that for A, the mass is 0.75, its velocity is 5 meter per second to the right, so it will be positive. 0.75 multiplied by 5 plus ball B is at rest, so we can write it as 1.8 multiplied by 0 equal. For ball A, we don't know what's the velocity, so we'll just keep it as v. So 0.75 multiplied by v, mass times velocity, plus ball B, this mass is 1.8 and the speed is 1 meter per second to the right, so positive. So 1.8 multiplied by 1. If you solve this, v will come out as 2.6 meter per second. Next, a 0.035 kg bullet strikes 5 kg stationary piece of lumber and embeds itself into the wood. That means it is stuck in the wood. And then the piece of lumber and bullet fly off together. So it is perfectly inelastic collision. They stick together and move together with 8.6 meter per second. What was the speed of the bullet before it struck the lumber? So let's just quickly draw a simple diagram to understand this. So there was a bullet whose mass is given to us as 0.035. We don't know what was its speed, so let's just write it as v. And then there is wood whose mass is 5 kg and it was at rest. This is before collision. After collision, the bullet is stuck in the wood and they both move together with 8.6 meter per second. Because it's stuck, so the mass will be mass of the bullet. So this is wood plus bullet. So I have to add the masses. 5 plus 0. How much is that? 0.035. So that will be 5.035 kg. Now I can apply conservation of momentum. Total momentum before collision is equal to total momentum after collision. So total momentum before, we had bullet 0.035, we don't know what's its speed, so we'll write it as v, plus 5 kg wood, it was at rest, and then later they joined together, so their mass is 5.035 and they moved together with a speed of 8.6. And we can solve this equation to get the value of v, which will be 1237.2 meter per second. Next, a 1.2 kg block and 1.8 kg block are initially at rest on a frictionless horizontal surface. When a compressed spring between the blocks is released, 1.8 kg block moves to the right at 2 meter per second as shown below. What is the velocity of 1.2 kg block after the spring is released? So again, we don't know what's the speed, we'll write it as v. So remember that before releasing the spring, the whole system was at rest. So P total before, again conservation of momentum, will be equal to P total after. What is before and after? Before releasing the spring and after releasing the spring. So before releasing the spring, the whole thing was at rest, so momentum will be 0. After releasing, 1.2 kg was moving, but we don't know what is its speed or velocity, so we just write it as V. And 1.8 kg, we know it was moving with 2 meter per second to the right, so 2 meter per second right means positive, so we'll just write it as 2. If you solve this, we'll get this answer as negative 3 meter per second, which shows that block which is having a mass of 1.2 kg is moving with 3 meter per second in the left direction. So negative means it's going to the left. Okay, so that ends the discussion of IPQ for end of term exam.